Here we have another rearrangement problem, but let's do the analogy with the glycine here. We notice that in the glycine, which is the allylic phenylic ether, we have two double bonds and they are two atoms away, the oxygen and another carbon. So in the case of the cup, that's what we're going to do to identify those. Here are two carbons, but instead of being oxygen and a carbon, but it's very similar system. So again, we are two positions away, the two atoms away. Now we're going to be redrawing this molecule to make a cyclic transition state, similar to what we did in the case of the, here we did glycine rearrangement, which is a 3-3, remember? And now we're going to be doing a cup 3-3. So now I am drawing, notice I'm going to do these. These are my, say, these two carbons. I'm going to keep that same strategy so you keep track of what I'm doing. These two carbons, and now I have a double bond. So this here, you will have a double bond. And I have a metal, metal, metal. So that's that. Now it is a cyclic transition state. We can see that. And now similar to that, we're going to be breaking this bond at the allylic portion. So now I'm going to be breaking that bond, making a new sigma bond between these two. This time let's highlight it in another color. That's my new sigma bond, and what I'm showing here is the bond that breaks. And doing the same thing, let's do numbers 1, 2, 3, and then 1, 2, and 3. So it is a 3-3. That's what COP is. And now let's redraw the molecule that results. I'm making a new sigma bond here. And now this has metal, metal, and here I had another metal double bond, and oh, I forgot one arrow here, very important. So now and that's a bond. Notice that, let's do the two blue dots. That's a bond that broke, and that's a new bond that formed. So let's keep the numbers that we did before. We have done this 3. 3 is a new bond. So 3, 2, 1, 3, 2, 1. And now to give the product, if you were asked, or maybe multiple choice question, depends. So, but if you were asked to give the products as a strategy, recognize that this is similar to that, fold it over to make a cyclic transition state, and then do identify the bond that you need to be breaking. Next step will be simply redrawing that in extended conformation. So now what I have here, for example, I can have an alkene, that's terminal, and I will have this is this carbon here, and that metal group. At the next carbon, I have two metals. The following carbon, let me draw it just straight, and so I don't need to be folding that anymore. Gonna keep doing my zigzag. So that's a carbon. At the next carbon, I'm gonna have a propyl group, and next, so this is 3, and then I have a double bond and a metal. So that's a way of drawing that. So again, this is, if we were doing numbers, this is 1, 2, and that was 3. And that's a new bond, 3 and 3. And I think I have an extra carbon. So because the propyl group, good thing that I did the numbers, because now I have 3, and then in carbon 2 is actually the aldehyde. So it will be that. So I think it's a good idea that happened, because now that can show you to keep track of those numbers. So 1, 2, and 3, and then the bond is in 3, 3. So 3, 2 is a double bond, and 1. Okay, so same strategy. So I do recommend that we do the numbers so that we keep track of what are we drawing.